Awesome. So the chat GPT name title of this talk is Demystifying SwiftSyntax, Unraveling the Magic of Abstract Syntax Trees, or ASTs. I wanted to choose something relatively wordy because, as you'll see, the syntax trees get very long very quickly. For those who missed it, my name is Michael Katz. I'm a distinguished engineer at Capital One, which just means that I have gray in my hair. So this talk, I'm going to go very briefly into the SwiftSyntax library and how and why to use it. Unfortunately, it's a pretty complicated library, and the topic of ASTs themselves could fill several weeks of CS course lecture. So to do it in half an hour, it's just going to be a very brief introduction, but happy to talk at length at any time later, or hopefully this will give you a place to start from to explore on your own. So I want to start with a story about a problem I ran into. And on advice of legal counsel, I'm just going to give a abstracted version of the problem. But let's say I wanted to create a report of all strings used by some function in my application, and figure the application has tens of thousands of files, and this function is called many, many times. Well, to do that, there's a couple of different ways. You can do search or grep, and that works well for places where I call the function and just give it the string. But what happens if some clever developer puts together a string like this? How do we magically get from there, the dot, dot, dot on the way to profit? This probably could be done with regex. Not a regex expert, but seems doable. But what about a case where you have some local variable that holds that string, and then the function is called with that string? Or worse, if you have a constant that defines the string that exists in an enum, and that enum is in a different file, and you're just looking at this call down here, and you're trying to figure out, okay, how do I get back to that string because I need to get that report put together? And that's where abstract syntax trees come into help. So what I needed was a syntax-aware way of finding all the calls to F, and then work backwards from those calls to find that input string. See if that's a little better. Okay. So let's start with the definition of abstract syntax trees. Very echoey. I'm trying my best here. So it's a tree, which means that it's hierarchical, and it's got a representation of the code or the syntax. What's important is that it's not just the text of your code. There's an understanding of the grammar and the keywords of the language that are being used. But one thing it does do is it abstracts things like formatting, spaces, new lines. Yeah. So let me run through an example. Let's say we have a very simple Swift function statement like let x equals 30. So what does the syntax tree for this look like? Well, we start off with this a variable declaration. We have assigning something to x. And then within that, we have the declaration modifier. In this case, it's a let. As you know, Swift can be a let or a var. And then there's the pattern binding. This is the pattern that gets bound to x. So there's the let keyword that's within the declaration modifier. And then within that pattern, we've got the identifier itself, which is our variable name. Then there's an initializer clause, which is the equals 30. And then we have an integer literal, which is the 30 itself. So rearranging it, this is what the tree looks like. As you can see, for each statement, it spreads out pretty far for something simple. And I would like to do more examples, but just given the time constraints, this could take a while. But I do find it fun as an exercise to go through code by hand and make these trees, kind of like coming up with big O notation. I mean, I think it might just be a big nerd in that way, but it's interesting to understand the code from this aspect. And this is, as I'll get into in this slide, how Not quite in the compiled version of your code looks, but on the way to the compiler, how the system thinks about your code. And the way that these trees are formed is the code goes into a lexer, and what the lexer does is it goes through your file, basically code, letter by letter, or in UTF-8 or UTF-16, obviously it could be more than one letter in a letter. But it puts together the tokens. So these can be things like our integer literals, our keywords, equal signs, braces, and it sort of figures all these things out. And then the tokens get handed to another program called a parser, and parser understands the grammar. It knows that for loops require bodies and that functions require return statements and things of that nature. And then it puts that all together, and that's what's known as the syntax tree. And the way that one works with syntax trees in Swift is with the SwiftSyntax library. This library is an official Apple library. It's part of Swift org, but it's hosted on GitHub, and you can insert it into a Swift program through the package manager. And there's the link to it there. It's not part of the Swift Foundation by default, so you have to import it. And then you use it by importing it. So there's several different libraries within SwiftSyntax. The two important ones for most cases are SwiftSyntax itself, which has the whole grammar, knows all the different node types, and then the parser, which takes code and turns it into the tree. And so here, I don't know if we can see that, but it has some text string. I hand it to the parser with the handy parse function, and that returns the tree, which will have a root of source file syntax. And then there's a handy dump function, which will print that to the console for you. So as you're working with these things, you can dump any node and it'll tell you that node and all its children in a pretty printed format. It makes it very easy to work with. So here's what the structure looks like for that two-line file. And I'm going to pull out pieces to make it a little easier to read. So the start here, for just the func keyword, we have the source file syntax root, then a list of statements, which are code block item lists. And that's basically all the top level statements in your file. So those could be imports, classes, structs, etc., functions. And in this case, we have a top level function, so that'll be one code block, and the next function will be a different code block. And so the first item is a code block item, and its item is a function declaration. So pretty simple, or not simple, but straightforward at least. Every node has a syntax, so the name of it will be something something syntax. So maybe it's function declaration syntax, variable declaration syntax, parameter items, and so on. And some of them have a list format or name in it. So like here, code block item list syntax, so you'll see argument list syntax and things like that. There's an indicator to you that there's going to be children, and so as you work with it, some trees have one child, and some will be lists with multiple children, and they'll all have that list syntax name to give you a clue as to how you iterate through its children. So the item itself within that function declaration syntax has a number of specialized things that are specific to declarations, such as attributes and modifiers. So attributes would be things you normally see with like an @ symbol, like @obc or @ibaction. Modifiers are things like public. The keyword itself, which is a special enum. So there's a bounded set of keywords that Swift knows about, and there's a SwiftSyntax parser for each version of Swift. So if you're working with different versions of Swift, you can download different parsers for that to make sure that you're getting the right tree out of it. Then the identifier, which is pretty much any symbol, are all identifiers. And here the function's name is greeting. So we have that there's the name. And then the function signature which has a parameter clause, and it knows about its left and right parens, and then parameter list, which I've cut out of this pullout, and a body. So each type of node will have specific members depending upon what it is. Function declarations have the function signature, it's got a body. String literals know about their opening and close quotes, and for pretty much anything you can think of, there are specific members that you can use to work with those. So it's abstract in the sense that it's abstracted from how things are necessarily formatted and ordered within the file, but it's not abstract in terms of like what the types are of the various things in the code. A couple different types of nodes that you might encounter. Declarations, which are where you define things like variables and functions. Expressions are things that evaluate to a value, so function calls, equal signs, etc. Statements could be code blocks, branches, return statements. And then there's a special thing called trivia, which the Swift parser maintains all the information about the original source file. So it knows about extra new lines and spaces, indentations, tabs versus spaces, all those sorts of things. Those are taken away in the tree, but they're still stored there within the node. So if you wanted to reconstruct the file, or you're doing some editing where you were moving things around, it'll tell you the position. So if you say like delete this function and you delete it by removing the line, you can get that information back as well. All nodes, you can get their parent, you can get the original text, where it is in the document, the trivia that I mentioned, and the list of tokens within that node. And all the different types of things have protocols associated with them. So like function declarations, class declarations, they support the declaration syntax protocol, and that means that they have things like modifiers and attributes and so on. So it's more things to know about as you work through it. Fortunately, Code Complete helps a lot in these cases. Less fortunate, there's not a ton of examples on the internet about how to use this, so like Copilot is not useful. There are two different ways you can traverse a syntax tree. So you can start with the root, and then you can navigate through its children, saying, get me the statement lists, look through those statements, find a particular class definition you're looking for, and then go through its member lists to find the member variable, things like that. You can also work with the specific node. So if you somehow have a link to that, pass it to a subfunction. You don't have to start with the root source file syntax. The advantage of working this way is as you walk through the tree, you can keep track of the context, so you know that where you are and what you've seen along the way. But the main way one works with these trees is with the syntax visitor, which is an object that you subclass and you apply on the tree, and it walks the tree for you, but it only stops at the nodes types that you specify, which basically means that when it operates on a node, it kind of plucks it out of its context in the tree. So it's efficient and easy to use, but you have to then manually keep track of any context that you might need along the way. So here's an example of a visitor that finds a class definition for a specified class. So it's created in its init, you give it the class name defined, and then because it's a subclass, it has to call super init, and there's this thing called view mode. Don't have time to get into it now, but this the Swift parser library is actually able to work with incomplete syntaxes. So if you leave off a trailing closing brace, things like that, has invalid syntax, but it's still parsable, and you can determine whether or not you want to deal with it. And that's what the view mode deals with, if it sort of inserts things in between to make it work or ignores them and so on. And then you override one of several hundred visit subfunctions. So there's a visit for every type of syntax, and I think there's over 250 syntaxes. So there's an implementation of visit for each one of these things, and then as they add more things to Swift. Each release, they have to add more of these subfunctions to it. But the default behavior is just to ignore it. So you only have to override those specific ones that you want. One trick, if you're writing one of these things, is I always use the code complete and just hit enter on the first thing that comes up, and then go back and edit the syntax type name rather than having to scroll through that giant list or trying to type it. It can get a little finicky, but they all return the same value, so it's pretty safe to do that. In this case, we're looking at class declaration syntaxes. So this would be where classes are declared in your file. Grab out of it the name node, and then the text grabs the thing like the inner HTML. If you've worked with like a DOM, it's the text that's within a particular node. So grab that so I can compare it to the input class defined. And copy and paste error there, but basically, if you remember in the previous slide, there was a class node member variable here. So when we find the one that matches, we set it to that. And then the return here is skip children, basically saying stop walking down the tree. It doesn't stop walking the whole tree, just this particular branch. Since it's a depth first search, it'll then go to the next one. So there's not really a way to early return completely from a visitor, but you can at least make it shorter. And then to call it, you have to instantiate the subclass, and then you call walk on your node. And this is where you can use either the root node or any node that you know about. And then that's a synchronous call, so it'll walk and that won't return until it's done with its walk of the node. And then one can assume, if we're keeping track of some node or value within that visitor subclass, like in this case, the class node, that it's either filled or not, and I can just print it out. And that's how you would visit and try to find that node. And then presumably you want to do something with that class declaration, like make a report of the number of different overrides that you have within a file or things like that. So in addition to just reading and parsing the tree, you can also manipulate the tree. And this is useful if you're building a tool that does refactoring, if you're making a linter autocorrector, you're trying to enforce particular code styles, like putting new lines after opening brace, things like that. You can have it do it automatically for you. Or for code generation, if you have some other tool that you're trying to generate Swift code out of, like some Kotlin or something. So here's an example of a rewriter. So it's very similar to the visitor. This also uses the visiting pattern, but instead of returning a continue or stop answer, it actually returns a new expression syntax that you can use to replace what you were visiting. So this one, it looks at a function call, so the function call expression syntax, looks at the last argument, and if it's a closure, we'll pull that out and then add it as a trailing closure, which is a separate child of the function call expression syntax. So basically, if you have a closure as the last argument, it'll turn it into a trailing closure. Something that might be useful and hopefully not too scary looking. The tricky thing is, when I was putting together this example, was getting that function call expression syntax right, because you have to know all the values that you have to fill out to make a valid function call expression syntax. So going back to the original problem that I had trying to find all the different places where I'm calling a particular function and pulling out their strings, I was able to do that using an a series of different visitors. So I have a visitor to find all the function calls that had the identifier being that function name, and then looking at the arguments to it, look at that first argument, and if it's a string, then I have my string. But if it's a variable reference is one type, then I'd have another visitor go and try to find the variable declaration that corresponds to that variable name, and then looked at its pattern and say, okay, is this a string or is it calling something else? And basically work all the way back to getting a string. And in the case of where I showed you the string was being constructed through addition, that's a particular type of expression, and so you can say, okay, these are pluses, and so I sort of reverse engineered the compiler in those cases to put together the string. So there's a little bit of work if you're going to get super fancy with it, but for my purposes, it served the need. And then I had that for one file, and then I was able to iterate over all the files to get that. And then I compared it with a grep on the number of places I've called that function to make sure that those wind up being equal. So I thought I'd throw in a little joke here. Why did the Swift compiler go to therapy? Because I had too many issues to resolve. So I don't know if you've ever seen this, maybe as you've worked with SwiftUI, I've gotten to a place where the compiler gives up because your code is too complex. The parser is like that too. Parser prefers simple things to parse, and the more complicated your code is, the harder time it has. In particular, performance-wise, the more that it has to walk through, both in terms of the visiting, but even just the parsing, it takes longer, and could be exponentially longer depending upon how many different branches and how fancy your code gets. Fortunately, there's a parse incrementally function on the parser. So if you make changes to a particular piece of the tree, you don't have to reparse the whole file. That's useful if you're using like a source code plugin, things of that nature. Also, when if you're building a visitor, is to walk the minimum amount of tree, either starting from not the root node, but from some known node like the class definition or something like that, and try to skip the children when you know that there's nothing further to go down that path. Also, watch memory growth as this thing, the trees are in memory as you go through it and it's adding to it. It can get quite large. Some limitations, the parser or SwiftSyntax only knows about what it parses. So if you give it one file at a time, it's only going to know about that file. So it may determine that some symbol is a reference, but it may not know if foo.x is a member access, or if it's a member function, or if it's backed by a generated getter, or anything of that nature. So it's not going to give you a ton of insights about your overall program or about your dependencies, things of that nature. Also doesn't understand data types. It understands symbols and tokens, but if you have generics or conditional values or type erasure, it's not going to give you a lot of insight there. It also won't tell you where the symbol is defined, even if it's in the same file. It'll just tell you what's a reference and what's a declaration. And it tries to work around syntax errors, but if there's a syntax error in your file, it still may not get the tree right. And the more complex your code gets, the more edge cases it might run into, especially, I'm not sure what the maximum nesting level is. I know you can specify one, but I think that there is a hard-coded at some point. Some best practices. So the easier your code is to read for you or your coworkers, the easier it'll be for the parser to read as well. So that's my statement on writing readable code. And this is a useful thing to integrate into tools, things that you might run once in a while. but try to minimize keeping them in the critical path. Probably only going to happen if you're making like a Swift editor, but even you can imagine a scenario with server-side Swift where you're making on-demand new services and deploying them while you're also like calling into it. It can add a lot of overhead to that. So I gave you an abstract example of abstract syntax trees, but there's actually some places where these come up a little more frequently. If anyone's written a custom Swift rule, you can write a regex one, or you can write one using SwiftSyntax. So you can actually do a deeper syntax-aware evaluation. Xcode kit, if you wanted to write a source editor extension, then you have access to the SwiftSyntax and use that to manipulate the code that's being edited. And then for those of you who were here last year, the macros talk for writing macros. So this is an example from Swift documentation of making a 4-character code macro, which I think enforces that a variable has 4 characters. And you can see there that it has some use of the SwiftSyntax there. It looks at the arguments, determines if it's a string literal, and then counts the number of segments. Here's some resources. The first one here, Swift AST Explorer. That's actually a website where you can put in arbitrary Swift code and it'll show you the syntax tree for it. And it's backed by the same Swift parser library running on the server. So it's really cool just to type in things and you can see how large those trees can get. And then the documentation and examples from Apple. So I give special thanks to friend and mentor Steve Johnson. I don't know if anyone here has been around long enough to use the old C compilers, but he's the author of the original Yak, Lex, and Lint. Someone I worked with early in my career. Was very generous with his time and taught me a lot about syntax trees. So this is a dedication to him. And thank you. It's my LinkedIn bio. For some reason you want that. And Q&A. Yeah.
I'm assuming this is only good for Swift grammars. You can't use it for custom grammars.
That is correct. I mean, you can write your own, like if you have a DSL on top of Swift, you can write your own grammar parser, and there are tools like this for every other, programming language out there.
Mike, am I right to understand that for your case, when you're trying to find the string, if that string defined as a num, remember, and you don't know file where it's defined, you would start from the very top of the whole app.
Yeah. Yeah. So
how efficient is it? How many hours you?
So it took me about 20 hours to make the tool, and it would have taken about 4 months to have every team who owned the code, schedule onto their sprints time to go through their code and then add to a spreadsheet and then put it in the format that I wanted and all that. So it was a trade-off in that way. Plus now I have this tool that I can reuse for some other things that actually have one thing with the enums defined in another file. So I actually added on top of it a symbol map so that it keep track of all the different classes and types and where they were located. It was able to then go back and find them. I scoped it within the module, so it didn't have to keep track of it across the entire program. We have hundreds of modules in our code, so I made that a little bit easier.
Thanks for the talk. It was really interesting. I can see the benefits of it, like when you're refactoring or finding some stuff in the large code base. My question is are there any existing tools for developers that are leveraging or using the SwiftSyntax as a library or dependency?
Yeah, so SwiftLint is the biggest one. If you use that, let's see if I can get. The examples here. So the Swift AST Explorer is the website I mentioned before. Swift Format, SwiftLint. I haven't used Barty Crouch. I think it's a Harry Potter thing. But there's some tools that are actually in the SwiftLint documentation that it points to. And obviously, I've seen a number of different custom macros out in the wild.
Thank you.
Hey, thanks for your talk. I think one of the things I've been hearing has been about the performance of SwiftSyntax, and that's been a reason also macros hasn't been much of a success. Have you had to deal with it? What are your thoughts on the performance?
Yeah, the performance is slow. So one thing that's recommended is if you need better performance, is there's a C version of this library, and to call that directly. Where I've used it has been tools, like these report generation things that we run, once a month at the most. So if it takes half an hour, it's not that big of a deal. I wouldn't put it in our merge check or anything like that. But obviously that doesn't work for the macro case.
I think you mentioned that the API exists, but how easy it is to map between AST and location in the source file?
So every node will tell you its position in that input string. So you can say, okay, where does it start, where does it end, and get that from there. And for things like quotes or functions, it'll tell you the opening brace and the closing brace as well are tokens that are within those.
Any last question? Last question? Okay.
All right, well,
Awesome.
Thank you so much for your time.
Thank you.
Today I'm going to talk to you about modularization, the benefit of it, and the things that you can use to automate it and why you should do that. Before we start, a little bit about me. My name is Mani. I'm currently working at LinkedIn and also on the side. I work at Kodeco as a tech editor and so Discord moderator. So if you're ever looking into the help or if you ever have any questions or want to chat, we have this Discord channel. Feel free to come. It's free. You just join and we can ask your questions and we are there to help you. Now for today, we're gonna go through modularization in Swift to make sure that we're all on the same page, what modularization means, how Swift is doing is kind of what Swift refer to module, what does it mean for your code, and what are the benefits of you going through that hassle of making your code breaking down into the different modules. Next, we're gonna go through the automation tooling. This part, I will do less coding. I will show you the tooling that you can use. They had great documentations, but I'm gonna walk you through the terminologies, the things that you need to know in order to be able to write your own automation, the tooling, the script that does that for you. If anybody needs help or want me to put out some sample codes, please reach out, let me know. I'm more than happy to put up a GitHub repo with some samples there. And then we will gonna go through some general tips and tricks. This is something that I've seen most iOS developers doing that can be a little bit hard to deal with or making it harder to create modules. And we're gonna talk about some of those. And then at the end, we're gonna have some time for Q&A. All right, first things first, what does module mean in Swift? So this is a definition from SwiftSytax. Basically, for simplicity, for focus of this talk, we're going to refer to the module as a framework or an application. So anything that you define as a framework when you go define a project or when you define an application, we refer to as module. This module can be a combination of one file, multiple files, and of course, if it's a dynamic framework, you can include resources and everything. What are the benefits of doing modularization on Swift? One is the way that Swift works. I don't know how many people here have used languages like C# that you can explicitly define your namespacing. Swift doesn't have that concept. Swift has implicit namespacing, meaning when you define a module, that module name is used as a namespace. So anything under that module name is under kind of like, it goes under that module name. So that module name kind of acts like a namespace and hides the types. That's how you can have multiple kind of like class names kind of having the same name. Like for people who had a kind of like fortunate enough to work with Objective-C and deal with this problem, like we don't have that in Swift because now we have this implicit namespacing. The other part is encouraging better coding. What does it mean? Most of this talks is coming from a few years ago when I was working at a company and we had a mono repo with one kind of like app target. And one of the things I started to do is break down our code into different modules. Part of the reasoning was when you break your code into different modules, when you want to add new code, you have to think about where am I going to add this? Which layer does it need to be in? Is it scalable enough? Is it dependent on other kind of like types? And the person who is reviewing your code now have to figure out why you're adding it there. And in general, it's going to make your code reusable, scalable, and easier to maintain over the time. And also, it's going to be faster to build. Why? Because basically you have this CPU that's going to go try to build your app. When you have this one mono target app that is going to include everything, you have these access controls that are internal, public, different things. Everything that is internal, if that changes, Swift compiler gonna go try to figure out what's the dependency and try to build the whole module. It's gonna take it a long time to try to figure out the side effect of your changes and everything. But if you break down your code into the smaller pieces, one is if you change anything that is internal in a module, Swift already knows that there is no public interface changes. So you can just build your module and be done with it. So basically, it's going to be faster to build. The other part is it's going to help the compiler to try to figure out which parts are independent from each other, which parts you can build in parallel. So it's going to take advantage of the cores and the CPUs that you have to build your app faster. To give you some numbers, with breaking out our kind of like app into the multiple modules, we reduced the incremental build by 30%. And that's how, by just moving the files around, that's how easy it is, relatively. Now let's see what's going on. Some of the things you also have to look at, like modularization is great. And most of these stacks is aiming for medium-sized applications, medium-sized developers. If you're working on like Capital One app, that is very large app, probably you have to deal with more of cautious when you do modularization. One is mixing Objective-C and Swift. You don't want to do that in a large code basis. It's going to be reduce your build time and it's going to have a very kind of like side effects on that. The other one is breaking up your modules. It's easier when your code base is small. You can just justify, okay, I have my UI, my data layer, network layer, and done. But when your code becomes complicated, when you have multiple teams working on different parts of the code, the dependencies can easily get out of the hand. So if you're working on a large code basis, most likely you want to invest into having an infra team, having build team to build out kind of like graph analysis on your builds and monitoring, profiling it, make sure that this modularization makes sense. Now that we know why we should do modularization, let's figure out why we need to kind of like automate this. Basically, as a solo developer, as a person who's working on the app, what you need to do when you want to create a different module. You go create, say, hey, I want to create a new Xcode project. You just name your project. You add it to your workplace. You go change your build setting to make sure that identifiers are right, or lowercase, the code signing is fine, the minimum deployment is set properly, and many, many other things. All of these things are error prone. Like I have done it. I've been forgetting many, many of the steps, even doing it multiple times. It's very easy to forget. And also it's making it hard to make it an exception from your colleagues to do that. So when you have a colleague that puts a code, you think that it's supposed, it should go into its own module, it's kind of harder to be that person to put a kind of PR commit to say, hey, can you go do all these steps to just move these 2 files in there? So that's another reason, just making this process automated, especially when you're working on one of those monorepos that you're gonna keep using this approach, gonna pay back. Now about the tooling. This is a part that I'm not gonna go into the details about this, and you will know shortly why. But for these toolings, there are two basic, two famous ones, and I believe these are the only two unless you want to write JavaScript. There's an NPM one. If anybody's want to write JavaScript, let me know. But CocoaPods and Twist, surprisingly, both are named Xcode Proj. They are open source. One is written in Ruby. CocoaPods is the longest one. It has very great documentation regarding everything that it has, and it's a library that I have used myself. I would say it's a really nice one. As a person that I don't knows nothing about Ruby, I could write a script to automate everything for me relatively easy. And if I had any issues, I could just open up a PR and then fix it under kind of like GitHub. The other one is from Twist team. If anybody is from, like, know them, I think the main developer or maintainer is from Shopify, and they're working on the tooling for iOS. Xcode Proj is written in Swift. You can use it in kind of like similar to the Swift PM, like you can just add a dependency and start writing. So everything gonna be in Swift. You can write the Swift command line and everything can be done there. Also, this is a project that is used by Bazel. If anybody is familiar with the Bazel build system, this is a Google build system to making things build faster. Both of them, they have great documentation, so I'm not gonna go into the details. But I'm gonna talk to you about what you need to do and the information that you need to have in order to automate this process. Because Apple being Apple, things that's supposed to be easy, they're not. So it's not as easy as let's use this library and create a project and add it. You have to deal with different, kind of like you have to deal with a PBX project. You have to know how the Xcode projects are organized, how Xcode knows what is the target, what configuration you're using, and how everything is overriding it. So these are the information that are going to be useful for you when you want to write your own, and then you can map this to the classes in those libraries and easily just write your own script. To make sure that we are on the same page, some of you might already know. So in a high level, the Xcode projects are usually set with a Xcode workplace. It's a file that includes all of your projects. Then you have your Xcode Proj, which is another kind of like Xcode format that includes your projects. Xcode projects, when you go create a new project, this is what you have. Then under that you have targets, configs, source files, resources, and everything. But how does Xcode knows how these are connected, which projects are related to the workspace, which targets are related to Xcode project, and other things? Like, let's go into more details. One is a workplace. Xcode workplace is nothing more than just a folder. So you can just right click and say open into the container, or if you have VS Code, you can right click and say open in a VS Code. Fun fact, that was my contribution to VS Code, to just be able to open these files into the VS Code for the same project I was working on. And this is why, because when you open in the VS Code, you can see the details. Xcode Workplace is nothing more than just a plist that uses general flags on your workplace, like how I compiled in this Mac version or things like that. So there's not much going on there. There's Xcode user data, which is Xcode users to know where your settings are, what you have done, which files you have opened, different things, user-specific settings. And then there's a contents Xcode Workplace, workspace data, which is nothing more than just XML. As you can see, it points to where you have your projects on. Now, you know, if you ever rename one of your projects, you can just easily come to this file, rename it here, and your workplace is gonna work fine. This is how your workplace knows which projects to show there. Now, let's get into more details of the fun part of this talk, Xcode Proj. You probably have been lucky enough to have mesh conflicts on the PBX Proj. I'm wondering why. this is it. Xcode Proj, again, is another folder. It has a shared data. Most likely is the place that you can find the schema. So when you go find different schema and tap on share, it puts it here. XC user data, again, is related to the user specific ones. Now you know why you see XC user data under your Git ignores. And then there is this project.pbxproj, which is a nightmare for all iOS developers. It's where you get your merge conflicts. It's where it holds everything related to your project. Files, which projects is that references to, the configs, everything is defined there. I've put up a very simple example of what you see here. Apparently this format is called ASCII next step property list. So it's very, very plist beginning before the XML coming out. That's why it looks weird. That's why it's scary. And that's where those tooling that I told you, they help you to work with this. But knowledge of this file, how it is organized, and opening it, looking at it, and try to see how, when you add a new project, which files are changing, what's going on, is very, very important, because you have to repeat the same flows when you're trying to write a script. You have to, just creating an Xcode project is not enough. You have to create an Xcode project. Then you have to open up the project that you want to add it to. Then you have to find this kind of like PB target dependencies part. Then you have to create a kind of like PB target dependency class, then add it here. Like all of these things is very, very kind of like detailed work that you have to do, but it's not that hard. It's just a bunch of code that you have to write and then go through. And at the end, you can customize a lot about what you're doing. One of the things also gonna be super helpful when you're dealing with automation and when you're dealing with abstracting your Xcode project creations and configs and everything is, I don't know how many people here are familiar with xcconfigs. Pretty much xcconfigs is a kind of like configuration that you can find. So everything that you have under the build settings can be overwritten through the xcconfig file. So you can just define the xcconfig file by going to the Xcode, kind of like tap on new file and then choose configuration. Then you can add it. Where it becomes powerful is it supports inclusion or kind of inheritance. So you can include multiple xcconfigs together. So in case if you want to, for example, share configs among your different targets, if you want to pass certain flags, like if you have your main module gonna have, like for example, I'm testing feature A and you want to have that compiler flag in your sub projects, you can have that in xcconfig that is used in all of your sub projects, and you're gonna have that compiler flag in all of your sub projects, and that's where the power of like having a xcconfig file comes handy. And the other part of it is, because it's a file, you can generate it. You can do many things with it. You can change it on the fly. You can add it to the Git ignores and have the compiler to generate that for you. And then your app depends on your environment variables, changes the compile flags and changes its behavior and changes the config files that it's using. So it's very, very useful for people who don't know how to use that. You can go to your project file. It's there. You can just define which config file to use. If you have any xcconfig file defining your project, it's going to show up there. Here I had a config.xcconfig in my project, so that's why you see it there. And to show you how that's getting reflected into pbxproj, at the bottom you can see when I add that, it uses the base configuration reference and it shows up there. Some of the things, again, when you get into this area, one of the things you're soon gonna try to figure out is what these configs means. Why am I changing this? What's going on? If I wanna add this into my xcconfig, but I don't know what the environment variable name is for this. One of the greatest tips I've learned is if you hold Alt and double click on anything under the build settings, it's gonna show you the environment variable, it's gonna give you the documentation, and that's very, very helpful if you end up to work in this area and wanna kind of like extract these into the xcconfig files. Or If not, if you go to the Stack Overflow, somebody tells you override this flag without telling you what that flag is. You can just easily go, Alt, double click, it's going to tell you what that flag is doing. And surprisingly, Apple has done a great job to document xconfig files, which is very rare. Here's the high level of what you're going to go through when you're trying to automate. Again, this is the part that I'm not going into showing you any coding samples because it's cumbersome. It's a lot of code to just create one simple project. If anybody needs, let me know. I will more than happy to set up a GitHub Proj and then even just write a customized like, GitHub repo for anybody to explore and play around with. But basically what you need to do, you need to create a PBX Proj through the command, like through the toolings, like both Xcode Proj, through the CocoaPod and Twist, they allow you to create a project. Then when you created your project, you go and then define the targets. So again, you have to manually create these targets and then you add them to the project. And then now you have a project that has 2 targets. Now you have to generate the files. You remember when you go to say add new file, like new project, it already has test, umbrella, header, files and everything. You have to write them all manually. So you have a bunch of code to generate those files for you. Then you add these files to your project. And then after that, you add your configuration that you want to use. And then after that, you add the reference to this project, to your main project. And there you go. You have generated your sub-project. This is very useful. This might sound like a lot of work, but to give you an example, I think we broke down one monorepo, 4 target app to 1 target app, and I believe 7 or 8 sub-projects by just doing this automation. And this made it super easy for me to go and comment to my coworkers' codes to say, hey, run this command and move this code into that sub-project. So now that you know how to do this work and what needs to be done, general tips and tricks, things that can help you other than knowing the whole structure and the whole flow. One of them is xconfig is very powerful. Like Cocoa pods, for those who have used it, it uses xconfig to override your configs of your app and how it injects this kind of config files to your app. Take advantage of xconfigs. Take advantage of the hierarchy that you can create. Take advantage of the things that you can do with this. One of the things I have done, which was super nice, was I'm going to talk a little bit more about it ahead, but was reducing a 4 target app to 1 target and use schemas to generate the configs. So we can switch between the environments of staging, dev, prod, whatever we wanted to do. I could generate the config files, put it there, and then everything was kind of like inheriting from each other. The other part is, if you're very into this part of the world and want to explore and want to save your colleagues from merge conflicts of PBX Proj, look into the alternatives like Xcode Gen is one of the ones that I found, which is commonly used, and Bazel has its own tooling. So basically what these tools are doing, they're getting rid of the PB Proj. They're getting rid of the Xcode Proj. They don't even, none of your repo is gonna have Xcode Proj in them because Xcode Proj is nothing really, it's just a bunch of the config files, bunch of reference to the files, and that's it, and maybe just resourcing. These are using YAML, which is a format used for server, usually like server configuration, things like that. They use YAML to define your format of the structure, and they generate the Xcode Proj for you on the fly or during a commit clone, like git clone or whatever you're doing, like they generate this Xcode Proj for you. So there is a way out if somebody invests into kind of like implementing this for your code base. The other part that I've seen that usually gets very downplayed is unit tests and UI tests. While you're automating everything going toward this path, also look into your like unit tests and UI tests. You're probably going to find a bunch of boilerplate codes, helpers that are used in across your unit tests, across your modules. Try to create at least one, for lack of a better naming, base framework for your testing and move everything there. And then you can share that module with your other unit tests, with your other UI tests. in order to prevent repeating yourself. Here's is the part that I was talking about. This is a common practice I've seen, and usually this is a part that can make it harder for people to move forward with modularization or move these things around. The right side has been my nightmare for a while, mainly because when your main app has 3 configurations, that doesn't get enforced to your sub projects. So sub projects are always debug and release. And if you want to do this, you have to replicate this all along. If you're happy with it, if you want to do that, go for it. But be aware of this is a limitation of the Xcode, and you have to include this for all of your projects. The other part is I've seen people defining different targets because they want to use different code signing, because they want to use different config settings, things like that. They go about this. One of the things I found, I can give more talks about if there's any interest, is there's this thing called pre-action for a build that almost is not mentioned everywhere, like anywhere. You can use this. You can write the scripts, and those scripts gonna get run before you build. One tricky part was, I think the first time that you run it, is if the config files are not there, it's gonna yell at you. I don't know if it's still there or not, but in the consequence runnings, you can have this pre-action build, which can run a command, and that command can generate XC configs and everything for you, and you have access to the environment. So you know which schema user is using. So instead of you defining different targets, you define different schemas. And then each schema generates the config file that overrides the configuration, build flags, and everything for you. And that's how you can control which variant of the app you want to build. Again, I'm not going to go into much of the details into that. If anybody needs any info, please reach out to me, or if anybody wants, we can have a talk about it. But try it out. It's actually a very, very nice feature that is almost, I haven't seen anybody use. And with that, we open for a question.
Thank you very much for the talk. 2 questions, if I may. First one may be simple, maybe not. Do you have an opinion on using frameworks versus local Swift packages for your modular code? And the second point, you made a really interesting observation that when you make your public interfaces within a module, you have to think a little bit harder about them, and I think that's important. In your company, perhaps, do you have a process by which you review public quote unquote public API, maybe to mentor folks on how to make APIs that will stand the test of time? Thank you.
No problem. Actually, latter one is easy. So by public, just to clarify, you're meaning about as a framework public interface. Those are usually comes up during a code review. It's hard to make any judgment call if you kind of like or have any automations. SwiftSyntax would have been a great tool if you could have just run it for a large code basis. But it's usually kind of like through the code reviews, and when you have your code reviews, like people try to catch like, why are you defined in this public, or why not just internal? Why not even private? Or one of my favorites is file private. Like I think file private is getting not much of the kind of it's not getting recognition that it should be. But that's usually during code review. There's no, as far as I know, no easy way to do that until we get to the part that Apple provides a better tooling. And that's been always a problem with Apple. They don't provide good tooling for a large code base. Usually the aim is understandably smaller size apps, more kind of like to the point apps. And your first question, to just confirm, is about using local packages. Well,
like for your example, do you use frameworks for your modular packages, or do you use SPM as your?
if I'm doing my own projects, SPM. I usually try to do SPM unless I'm working on an iOS application. Again, I'm trying to do SPM. There are still issues with SPM when you try to use that, especially when you include SPM in Xcode Pro. I don't know if it has been resolved, but again, Apple includes your SPM references into the PBX Pro, I believe, or somewhere there, and it includes the URL. So if you use SSH and I use HTTP, we're gonna have conflicts there all the time because it uses the whole flow. I don't know if they ever fixed that, and I have an open SO question about how you can enforce Xcode to use SSH. Apparently Apple uses HTTP if you override your local to use SSH, and your whole SPM is gonna fail. So you have to go change that to use HTTP. So again, Xcode being Xcode, I try to use SPM, but I don't sweat about it. If I have to, I just switch back.
A couple months ago, Apple released the Pickle configuration programming language. Do you have any prognostications as to whether or not they're going to move PBX proj and those type of files to it?
I hope so. I would really be happy if they do that. Yet I've done that, and I don't like. Apple has been doing many things that I've done. For people that don't know, I think PKL or something. Apple recently open source kind of like very similar to the YAML for people who know the YAML. For people that don't know, Apple released a language that is for kind of like configuring server size and things like that and file system. I hope they do. I don't know. Like they were supposed to be done with LSP, and they're still working on LSP. So.
I think you mentioned like some tooling you could use to build a graph of dependencies or something like that at the beginning of the talk.
No, I don't know on top of my head any tooling, but I can find it for you. I know. So I don't think it's part of that. Let's see if yeah, Twist, I think have one. I just want to say, so there are two things for people who might not be familiar with. One is Mobile Foundation, not the Microsoft one. No. It's hard to type with one hand. I think it's or mobile. No. So there's a Mobile Foundation. I can find it and send it to you.
Yeah, no worries.
If you heard of Mobile Foundation, it's so a bunch of the companies like LinkedIn, Spotify, and Lyft, I think, they gathered together and they just said, hey, we're not getting any support from Apple. We're kind of trying to solve the same problem like ourselves. For some reason, I'm not able to find it. Actually, yeah. So they started to kind of like create this mobile foundation and this, yeah, mobile native foundation. So this foundation is where most of, I would suggest for anybody who's interested, go check it out. I think this XC log parser is from, if I'm not mistaken, Spotify. Blue Pill, I don't even know, but I know it's widely used for unit tests, UI tests. I haven't seen anything regarding the dependency management. I can try to look at it. I know we use one at LinkedIn, but I don't know if that's open source or not. But yeah.
Cool, thanks.
In the beginning of your presentation, you mentioned Twist. Do you have any experience with that? And just curious your thoughts about it.
My experience with them has been just contributing to their GitHub. I know the developer, but just following on the Twitter and public. I know the developer is super nice person. The team who is working on it are very nice. And this is Code approach is something that is used by Bazel. So my kind of like, I don't have a personal interaction, but the professional is they're trustworthy. What they're doing is making great tooling for mobile, and it's open source. So if you find something that is not there, you can contribute to it. And by the way, this is the PKL for anybody who was interested that Apple released.
Thank you.
We're gonna do the ruffle thing.
Thank you very much.